Hello everybody and welcome to another YouTube video. So in today's video, I'm going to be discussing generators in Python. Now generators are highly related to iterators and would be considered a more advanced or expert level feature in the Python programming language. That said though, they're not overly complicated. In fact, I think I can give you a decent explanation that most of you, regardless of your Python knowledge, can understand. Well, with that said, let's dive into the video after a quick word from our sponsor. Before we get started, I need to thank HiCounselor for sponsoring this video. HiCounselor's Job Search Accelerator program combines AI-powered technology and professional mentorship from top tech companies to help recent graduates and young professionals get a lot more interviews and fast-track them to landing their dream jobs in tech in 6 weeks on average. HiCounselor has no upfront enrollment fees, and their program is completely free until you land a job. Admitted candidates get help with their resume, LinkedIn, networking, and much more. HiCounselor also uses a proprietary tool that does professional networking on behalf of their candidates. This, in combination with a unique network of over 250 hiring partners, mean candidates get 10 times more interviews on average and spend less time searching the web for jobs. Multiple job offers are common amongst HiCounselor candidates, and the program has a 100% placement success rate. You can submit an application for free through the HiCounselor website or attend an upcoming information session to learn more. Check out HiCounselor from the link in the description today. Alright, so let's go ahead and dive into the video. The first thing that I need to do before we can really talk in depth about generators is describe what an iterator is and talk to you about how iterators work in Python. Now, really, an iterator is an object that allows you to loop through a sequence of numbers or some sequence of data, some sequence of something, without having to store all of the different items in that sequence in memory. So I'll kind of give you an example of what I mean in a second, but a generator is really just a new form of syntax that was introduced in Python version 3 that allows you to create an iterator without having to go through kind of a more tedious and less elegant process. So generators and iterators are pretty much the same thing. Generators just use a new syntax and are much easier to create than kind of your standard iterators, which we'll see here in a second. So I'm going to start by explaining iterators, taking a deep dive on those, and then in the later half of the video, we will get into generators and how to use the new syntax to create more elegant iterators, essentially. All right, so let me start by introducing a problem to you here. Let's say we didn't have the function range and we didn't have a while loop, okay? No while loop and no range function. And we wanted to loop through the numbers 1 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, without using the range function and without using a while loop and without coming up with something super creative, just simply thinking about this, what we would probably do is the following. We might create some list, right? And then in this list, we could store our numbers 7, 8, 9, and 10, okay? And then what I could do is I could just loop through this list, right? I could say for element in X, and then I could just print the element. And quite simply, this is going to loop through all of these values. We're looping through the numbers 1 to 10. Now, the problem with this is that I'm storing these 10 numbers here in memory, in a list. And for me to be able to loop through them, I need to store all of them in a data structure. Now, that's not very efficient, and with 10 numbers, this is fine, but you can imagine if I wanted to loop through 100,000 numbers, a million numbers, a billion numbers, it really doesn't make any sense at all for me to store the entire sequence of numbers in memory, especially if all I'm going to do is process them one at a time, and I don't need to know what all of these are as I loop through the numbers. So it doesn't make any sense for me to store this in a list. And that is why, of course, we use something like the range function, right? So I say for, I guess I won't say element, in this case I can say I, for I, in range, and then I do something like 1 to 11, and then I print element. Here, I get the same thing. Oops, sorry, I'm going to print I, not element. Here, I get the exact same result, right? Looping through the range of 1 to 11, except when I use the range function here, I don't actually need to store all of the numbers 1 through 10 in a data structure. And so if I were to look at the size of this data structure versus the size of the range function, we should see that this data structure has a larger size than the range function because the range function doesn't need to store all of these numbers. And in fact, if I want to do that, I can. So I'm going to import sys, and I'm going to say print sys.get_size of x. We can see that that is giving us a value of 136. And then I'm just going to take my range function here. I'm going to print sys.get_size of, and then of the range function. Does that look good? Okay. And we see that we get a size of 48 for the range function. So obviously this doesn't prove exactly what I'm saying, but just trying to show you that this uses more space than the range function because the range function doesn't need to create this list for us to be able to loop through it. And that is because the range function returns to us an iterator. Okay, so now we can really talk about what an iterator is. So an iterator, as I described before, is really something that allows us to loop through a sequence of numbers or of some data without having to store them all. So the range function is a great example of an iterator because it lets us loop through all of these numbers without having to store them in some data structure. Now, I'm going to show you one more example of an iterator in Python that you may not know is an iterator and just kind of describe briefly how that works because it will bring our understanding. So I'm going to use this function called map. If you don't know what it does, don't worry. Once I write the code here, I'll explain exactly what it does. I'm going to say I to the exponent 2 and then pass x. Okay, so what the map function does is it takes some data structure, in this case we have a list, and it maps all of the values in this data structure to some function. So pretty much it applies this function to all of the values in the data structure, and then it actually returns to us an iterator that contains all of the results of this function called on all of these values. So essentially what this is doing is generating the squares of all of these values. And so if I were to look at this as a list, I would have 1, 4, 9, 16, so on and so forth, because I'm applying this function right here, which is just generating the square of all of the values from the list. Now, the thing is, this map function here doesn't actually store a new list that has all of the results of these function calls. This function here is actually a generator or an iterator that allows us to iterate through all of these results, so all of the results of these values passed to this function without actually storing them. I understand that's a little bit confusing, but if you look at y, if we print out y here, we see this is a map object. This actually isn't something that's storing all of the values. It's not a list, right? Now, if I were to look at the list representation, so I print out the list, we see that we do get all of the values that we expect, but this is not the default behavior. It's not storing this list. It only creates this list for us when we call this list function. That's a common misconception. So let me show you what I mean and how this is actually an iterator. So if I go something like for I in y, and then I print I here, we see that we get all of the values that we expect. The thing is, we only generated these values once we started looping through this map object. They weren't already generated and stored in memory. Like when I say for I in y, on the first iteration, it sends this 1 to this function and gives me the result. Then it sends this 2 to the function, gives me the result, sends the 3 to the function, gives me the result. It's doing it while I'm looping through it. It didn't do it before and store all of it in memory. And to give you one last proof here, I'm going to print the sys.size of, or I guess this is get size of, and then of y. And let's see what we get. We get a size of 48. Again, if you compare that to, let's say, the list of y, okay, you'll see that the list of y is much larger than simply y, because when we do the list, it actually generates the list for us. Hopefully this is making sense. The whole point is that we didn't have to store the sequence in memory. We could generate the sequence as we looped through it, and that is really what an iterator is. Okay, so now I want to dive into how an iterator actually works and how you create an iterator. So really, what a for loop is doing is it's calling a special method on all of these iterator objects, so this map object, this range object, that gives us the next item or the next piece of data in the sequence that we're looping through. So there's actually this function here, and it's called next. And what this does is give us the next value in the iteration through an iterator. So if I go here, and I print the next of y, you can see that we get 1, right? And then if I print this again, we get 4. And if I print this, again, we get 9. And again, I did not mean to create a new file there, we get 16. And then notice here, right, I've gone through 4 times y. And now if I start looping through y, for I in y, and I print I, we're going to start looping at 25 because that was the next value in the iteration. Notice I didn't have 1, 4, 9, 16, and then those repeating again and then looping through the rest of the values. It continued right at 25. And just to make this even more clear, I'm going to say print for loop starts, okay? And notice we have 1, 4, 9, 16, the for loop starts, and then we continue through the rest of the iteration. Hopefully this is kind of making sense, but really what a for loop is doing is it is calling this next function on your iterator object, and that is returning to you I, which is going to be the next value in the sequence. So when I've already looped through the first four values in the sequence, and then I go to the for loop here, well, the for loop is just going to continue to call next until eventually there's no more items in the sequence, and so that's why it starts after we've already looped through the value, if that kind of makes sense, or it starts where we left off looping through the rest of the sequence. Hopefully I'm articulating that okay. So hopefully that makes sense, but that is what an iterator does. That's what a for loop does. An iterator has this kind of next method on it, and when we use this next function, well, we get access to the next value in the sequence. Now, the same thing works when I do this, y dot underscore underscore next underscore underscore. So this is a dunder method, a double underscore method. Some of you may be familiar with that, but the next function is the exact same as me calling underscore underscore next underscore underscore on an object. And to just show this to you, if I run this, you see we get the same thing. Okay, nice. So that is how that works. Now, what I'm going to do for you is write a for loop, or write what the actual implementation of a for loop is, so you can see how it actually works on an iterator. So this is our for loop, but if I were to write this for loop and kind of peel away, the disguise here where it says for, this is what it would look like. If I say while true, and then I'm going to try to get the next value in my iterator. So I'm going to say value equals next, and this is going to be of y. And then I'm going to accept. The exception here is stop iteration. I'll describe this in a second, and then I am going to break, and I'll just print done, and then here I will print the value. Okay, so these here, this for loop and this while loop are actually identical. Let me get rid of this though, because we don't need this anymore. Okay, again, yeah, so this for loop and this while loop are identical. We are looping through this y iterator. So in this case, I'm saying for I in y, and then what this for loop actually does is what I've written here. We have an infinite loop, so we have while true because we don't know how many items are in the sequence. And then what we do is we try to get the next value from our iterator. So we keep calling this next function, or in the same way, we could say y dot underscore underscore next underscore underscore, but the next function is kind of convention. Then we print out the value, and then we accept stop iteration. So if at any point in time there is no more values in the sequence or in the iterator is going to raise an exception. This exception is stop iteration, and in that case we end the while loop and we're done. So just keep in mind, this for loop and this while loop are literally the exact same thing. All right, so let me delete this for loop here and just run this for you, and you can see that this works, right? We print out all of the values, and as soon as we find this stop iteration error, we print done. Now, let me show you what happens if I don't have this, this except here. So if I just do this, I just try to get the next value from my iterator, and I run this, notice we get an exception, and it just says stop iteration. That's obviously why I accepted the stop iteration error, because, well, you need to do that, otherwise your program is going to crash, and that is exactly what a for loop does. Okay, so there you go. That is the basics of how you loop through an iterate. Now, let me show you kind of doing the same thing, with the range function. So let's say x is equal to, in lowercase, x is equal to range, and then we have 1, 11. That's the range we want to loop through. So let's start by just printing x. Now notice when we print x, we actually just get a string representation of the range function. So this is a string, it just prints this out for us. And now watch what happens though if I try to call next on x. If I do this, notice we get an error. It says range object is not an iterator. Now, the reason it's not an iterator is because for us to actually get the iterator from the range object, we need to call another special method, which is called iter. So there is this iter method, or this iter function, that returns an iterator from an object. And there's also the dot underscore underscore iter underscore dunder method. Now, what this iter method does is the exact same thing as this iter function. If you call the iter method, it's literally identical to calling the iter function, just like the next function and the next dunder method. So the whole point of me saying this to you, though, is that if we want to get the iterator from x, we need to call iter like that. So if I call iter there, now this is actually going to work, right? If I get the next of iter x, we don't get an error. I didn't print out what that was. I can print it. You can see that that is now correct. There you go. So that is kind of how that works. So the whole thing is when I do something like for I in x, what actually happens is we're saying for I in the iter of x. And then it calls the iter method, gets the iterator, and then calls the next method on the iterator object that we got from the object we're looping through. Hopefully that kind of makes sense, but the whole point is you start by calling that iter method. That iter method returns to you the iterator, which has a next method on it, and then you call the next method on the iterator. It's a little bit confusing because on map, you don't need to do that. On range, you do need to do that. The whole point is that there's kind of two methods that make up an iterator. One is the iter method, the next is the next method. So now what I'm going to end off the explanation of iterators by doing is showing you how you make your own iterator using kind of the old legacy syntax, not the generator syntax. So the way you do this is you create a class. So I'm going to make a class. I'm just going to call this class iter. Now you can define the init and any other methods in this class just like you would for any other class. So I'm going to say self. I'm just going to take some value n. I'm going to say self.n is equal to n, and n will kind of be like the maximum value I want to go to while I'm iterating. All right. Then if I want to make this an iterator, I need to implement two methods. Those methods are iter and next. So I'm going to say define __ iter like that. And all I'm going to do here is I'm going to return myself. And I'm going to set self.current equal to 0. So when I call the iter method, I'm going to initialize something, this current variable that's going to store the current value out of my iteration. And then I'm going to return myself. The reason I'm returning myself is because I'm not creating any special iterator object here. I'm just returning this object itself, the current instance that I'm calling this on, so that it can use that as the iterator. Might be a little bit confusing, but we'll keep going. So now I'm going to implement the next method. So __ next __. And inside of here, what I'm going to do is say self.current plus equals 1. And then I'm going to return self.current. Now I need to change a few things. First, I'm going to make self.current actually equal to -1. And before I return self.current, I'm going to say if self.current is greater than or equal to self.n, then what I want to do is raise stop iteration. Okay, this is kind of the way that you need to implement an iterator. Inside of your next method, you have some base case that raises the stop iteration, or some exit case that raises the stop iteration, and then you increment your iterator or do whatever it is you're doing with your sequence, and then eventually you return the value. So the reason I'm initializing current at -1 is because I start by adding 1 to whatever my current iterator value is. So -1 goes to 0, so the first value I return is 0, then 1, then 2, so on and so forth. And then eventually I raise the stop iteration error. And it's not until I call this iter method again to get a new iterator do I reset my current value to -1. Okay, hopefully that kind of makes sense, but let's just make the iterator now. Let's say x is equal to iter. Let's pass the value 5 in here. And now let's try to loop through this iterator. So I'm going to go for, and I'll say I in x. And I'm going to print I. And let's see if we get an error. No, we don't. We get 0, 1, 2, 3, 4. There you go. So we've just created an iterator. We can now loop through this object because we have the iter method and because we have the next method. Now watch what happens if I remove the iter method though. If I remove this, it says iter object is not iterable. The reason it's not iterable is because it couldn't get the iterator from it because we didn't implement the iter method. Now let's remove this next method and let's see what happens here. Returned non-iterator of a type iter. So it returned something that didn't have the next method on it. So that means it is not an iterator. Hopefully that is clear, but that's how that works. Okay, so now let me just show you how we would manually call the next method on this. So I could do something like print and then next of x. But when I do this, take a guess at what's going to happen. Notice I get an error. It says iter object has no attribute current. The reason it has no attribute current is because I didn't create the iterator object first, or I didn't initialize the iterator by calling the iter method. I just called next. So I would need to say like iter is equal to iter of x, and then I could call next on iter, okay? And then notice I get 0, and then if I call it again, so let's do it here, I get 1, 2, 3, so on and so forth. Okay, so that is the old school way of creating an iterator. Now I'm going to introduce to you, generators, which is the much more elegant and nice way of creating an iterator. So the generator syntax is quite simple. You create a function. So in this case, I'm just going to say define gen. Take in any parameters that you want. In this case, I'll take in n. And then what you do is you use the yield keyword instead of the return keyword. I'm going to explain exactly how this works, but let me just make the exact same iterator I made before using the generator syntax. So let me say, actually, I don't need self. I can just say, we'll use a for loop actually, for I in range, and then this will be n, and I'm going to yield and I need to spell yield correctly. I'm going to yield n. Okay, so this is exactly the same as that class that I just created, and notice how much simpler this is. So I'm sure this probably still doesn't make much sense to you, but let's just loop through it for I in, and then we're going to say gen of 5, like that, print I, and notice that we get, oops, sorry, it's yielding n, that needs to yield I. My bad, we get the exact same thing that we got before. So the way that the generator works is when the yield keyword is hit, it pauses the execution of the function and returns this value to whatever is iterating through this generator object. So in this case, I'm saying for I in gen 5. So I'm looping through my generator here, passing the value 5 to it. And inside of my generator, I create this for loop. And in this for loop, I'm looping up to 5 or up to n. So in this case, 5, but not including 5. And I'm yielding I. So as soon as I get through the first iteration of this for loop and I is equal to 0, I yield 0. And what that means is I immediately pause, I stop. All of the information about this function is saved, so it's stored in memory. And then I go to this for loop and I print whatever the value is that I yielded. Then what happens is the function or this for loop continues. So we go through the next value, we call next on this generator. That then has the for loop run again. So then we get the value 1. Then we call next again, we get the value 2, 3, 4, so on and so forth. The important thing to understand is when yield is hit, the function execution is paused. It's not terminated, it's not done, it's paused. And then we return to it and continue running whenever we see the next keyword again, or whenever we call the next method or function on this generator. So to do this manually, I could say, I guess I'll just go with x is equal to gen of 5. And then I could say next x, let's just print this like this, okay? So if we do this manually, okay, notice we get 0, 1, 2, 3. So pretty much this generator syntax makes the next method and the iter method implemented for us, so we don't have to manually write them inside of a class, and instead we just use the yield keyword. Now I'm just going to show you in a different way how we could do this. So let's say we take no parameters here. What I can actually do inside of this function is I can yield multiple times. So I'm going to yield 1, then I'm going to yield 2, then I'm going to yield, again, I got to spell that correctly, 3, then I'm going to yield 4. So now when I do this, notice you get 1, 2, 3, 4, because what happens is we yield 1, we pause the execution of the function, we print the value. We yield 2, we pause the execution of the function, we print 2, right? So on and so forth. And if you want to make this even more clear, we're going to print pause 1, okay, pause 2, pause 3. And actually, now that I think of it, yeah, okay, this is fine. Yeah, we can do that. So let's run this and notice you get 1, pause 1, 2, pause 2, 3, pause 3, and then finally we have 4. And the whole point is that we didn't need to generate this entire sequence of numbers to be able to loop through it. We were just returning it as we needed those values. All right, so at this point in time, you're probably asking yourself, what is the point of this? Maybe you understood the examples I went through. You know when you use the yield keyword in a function that generates a generator or makes that function a generator. And as soon as you hit the yield keyword, the execution of the function is paused, but the entire state of the function, all variables, everything inside of it is saved, right? All of that's saved, but the execution is just paused, and then it can be returned to when you call the next function. However, again, what is the use case of this? Well, really, the use case of a generator is such that you can loop through a sequence or some large amount of data without needing to store all of it. And the situation in which you use a generator is when you do not care about the data before or after something in an iteration, you only care about the current piece of data that you're looking at. So a super simple example is you want to print out all of the numbers in a sequence. You don't need to know the previous or the next number in the sequence or any, of the numbers in the sequence. You only need to know the current number in order to print it out. And there's a lot of times when you're looping through some type of data structure or something where you don't care about anything before or after the current element. You just care about the current element. And if that's the case, you use a generator. However, if you do care about stuff forward or after, before or after the current element, then you can't use a generator because you need access to whatever's before, whatever's after, or maybe you need access to everything that's to the right in the list, everything that's in the left of the list, or sequence or whatever. In that case, you can't use a generator because the generator only gives you the current value. You could have a generator give you maybe the second, third, fourth value, but if you need access to the entire sequence when you're processing one element, you can't use a generator. Hopefully that's clear. but that's kind of the differentiating factor on when you would use a generator or when you would use some data structure to loop through. But I want to give you a very real example here of when you use a generator. So let's say you have a very large file, maybe a file that has billions of lines or just a ton of lines. It's going to take maybe like a few days of processing power to actually go through and process this file, depending on what you're doing with it. And let's say simply in this file, you want to look for if a word exists. You don't really care where it exists. You just want to know if a word exists in this file. Well, the first way you could do this, find if the word exists in the file, is you could read the entire file. This would be the standard way. You read it all into memory, and then you loop through the data structure you have that represents the file, and you see if that word exists. That's the first way that you could do it. However, you don't need to know every single line in the file at one point in time. You only need to know the current line that you're looking at, and then you can determine with the current line if that line has the word that you're looking for in it. So you look at one line at a time. You don't care about all the lines before, all the lines after. You only care about the current line. If you find the word, great. If you don't, you move on to the next line. In this situation, you would use a generator. And what you could do is yield one row of the file at a time, so that rather than reading in the entire file and taking up, maybe gigabytes of memory, you're only taking up a few megabytes or gigabytes or bytes in your memory to store one line at a time. And then as you look through that line, you move on to the next line if it doesn't have the word, or maybe you stop the program if it does have the word. So I'm just going to copy in a function here that shows you exactly how you would do that. This function is called CSV reader, and all you do is you pass a file to this function. What it does is it opens the file, and then it yields one row of the file at a time. So this way, you don't actually need to, read the entire file in at once. You just read one row. You can process the row, see if it has a word, and then continue on from there. So that is kind of my example. Hopefully that maybe cleared it up on when you would use a generator. So sorry for the abrupt cut here, but I realized when I was editing this video, I forgot to mention an important part of generators, which is generator comprehensions. So there is actually another way to create a generator that does not involve creating a function. Previously, the way we made a generator was made a function, and we just put the yield keyword in it. As soon as you put the yield keyword in a function, it's a generator. However, another way to do this is with a comprehension. So let me just show you. I can say something like x is equal to, I'm going to put the syntax for a tuple, so open brace and close brace, or open parenthesis, closing parenthesis. Then I'm going to say I for I in range 10. Now, this is a very stupid generator. You never make this, but I just made a generator. And to prove this to you, I'm going to print x. So when I do this, notice I get a generator object. So whenever you do a comprehension like this inside of the parentheses, this gives you a generator. So now I could print out the next of x. And when I do that, I get 0. I could do this again. Okay, I get 1, 2, 3. And then I could loop through x. I could say for, j in x, print j, and well, we get the same thing, right? That's all I wanted to show you. That's another way you can make a generator with a comprehension like this. Of course, you would do something that probably makes more sense than this, that is a bit more advanced. There's another way to go about doing that. All right, so with that said, I am going to end the video here. I hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another YouTube video.